I don't understand that part, but I understand this part now.
Oh, good. Just keep staying a step behind.
Weird.
All right. Now, here's what I'm going to do to this statement, this equation. This is not meant to be a shortcut in any way. In fact, this is a confusing way to write the idea that if you want to add up n terms, you just add them up like this. Okay? But here's where I'm going to make it more confusing in an ultimate effort to clear the darkness.
That is an S still, right?
This means sum, yes.
Okay.
Okay, yes.
Get worse before it gets better.
Yes. Now, I'm going to multiply both sides of this equation, every single term on both sides, by my common ratio r. So now this first term is going to have an r. And this second term is going to have an r squared. This third term will have an r cubed.
That makes no sense to me.
Yeah, that's because it's like x times x, you get x squared.
Oh, so you're pulling out the... Oh.
So I'm multiplying everything on both sides times an r, which will now get me to an r to the n here. Okay, r to the n minus 1 times another r becomes r to the n. It becomes 1 degree bigger. Okay?
Is that the basis for the derivation of powers?
I don't...
Getting there. It's mixed in. Okay. This is just a really, Martina, this is just a really ugly way to say we're adding on a bunch of numbers together and they're all getting bigger by the same multiple each time.
Oh, okay.
This is an ugly way of saying we're rewriting the same thing and we're multiplying everything by that multiple from the first equation. So if it were this series, yeah, this is like doubling everything.
But that's the next step.
Yeah, well now, here's where it's going to get really exciting. I'm going to subtract these two equations from each other.
Thanks.
What?
Which two? This is going to seem like a complete sheet to some of you. Now, if I subtract these two equations from each other,
So then wouldn't you just get R?
well, close. A sub 1 times r has got an equivalent down here. A sub 1 doesn't.
So you get
A sub 1 times r will have this subtracted from it.
Well, so they're all gone. The only thing you have
except
left
for
over
a
is a sub 1.
r to the fourth.
Because it keeps going.
Now, this has one somewhere presumably in there too, on the dot, dot, dot.
No, wait, no, it's all. Wait, isn't
No,
it all
but those two aren't the same. The two at the
These two
end.
aren't the same, but if this is n, does there have to be an n minus 1 before it?
No.
Yeah, there actually does, because we're going in order.
Oh, that does.
So yeah, so if this is like 19, there has to be an 18 before it. If this is 27, there has to be 26 before
So
it.
it's a sub 1 plus a sub 1 r to the n.
Yeah, so no matter how, there can be a million terms in between these two, and we just made them all disappear. This could represent 5 terms in between, this could represent a million terms in between, but if you subtract these two things on this side, all that's left over here is the first term and the last term.
My question is, why do they call it adding terms if you subtract them?
Well, addition and subtraction are the same thing. As far as we're concerned, addition and subtraction are the same thing, multiplication and division are the same thing. Arithmetic refers to adding or subtracting, geometric refers to multiplying, or multiplying by a fraction, which is also dividing. We're not picky here. We're no longer discriminating on the basis of up or down or larger or smaller. Yes?
So basically, once you know, like once you set it up and all that stuff, what the only things you're looking at is the last terms and the first term.
Everything else will disappear in the subtraction. Now the problem is, this side is not equal to the sum. The whole point is to have the sum equal to something. But it is a common factor of both of these terms, as Drew, I think, was about to point out. And what's left,
He wasn't.
is 1 minus your common ratio. Okay? So now I'm going to divide both sides by that common ratio, and I'm going to get a fraction, a sub 1 plus...
Wait, what was the ratio?
Oh, you can't do that.
It depends. It could be the ratio. This is whatever the multiple is between all these terms. In my first example, the common ratio was 2.
Why'd you pull out 1 minus r?
So that I could divide both sides by 1 minus r and get a formula for the sum up to the nth term of any geometric series. Okay, now I'm going to do one more trick. I've got a common term up top. This is a little bit more complicated than what little Carl did. But it's the same idea. Let's make sure I have it. Nope, I haven't.
You can't do that. I mean, yes you can, but what the hell?
My apologies, I made a mistake through here. This was subtraction, so that means this should have been subtraction all the way through.
I hate you.
Missed them.
Me too.
Well, okay, it's not like it's that big of a,
Hey,
like...
but I'm in pet. I'm going to
Alright, sorry about that. So yeah, that's supposed to be subtraction. Okay. This always felt a little bit like a cheat to me. Like you can make the middle million terms disappear if you want.
Wait, so, question.
Yes.
But how do you
So-
do an A?
Let Lauren finish her question first, and then.
Okay, so you said that the second one,
Uh-huh.
the R sum of n,
Yeah.
is actually minus n.
Well,
Where's the minus
we're
sign?
subtracting these two equations from each other.
You didn't say that.
I did say I wrote it here. See this top one minus this bottom one. I just
Well,
blew
you
it.
didn't indicate it in a nice way. Okay, fine. Never mind.
Hang on, this is for
Minus
Lauren.
These two. Okay. Sheesh.
Lauren, how's that in red?
That works.
Okay, good. All right, we're subtracting the whole thing. If that makes it clear.
I was confused why you have a line there. Cause I was
Right.
like, what? Okay.
So the
That makes
cool.
more sense.
I'm glad. So the cool thing about this is if I say
How do you pull out an ace of one?
it's a common factor to both. Whatever the first number is up here.
Duh. Okay.
All right. Now I'm going to do an example of how this plays out and how you can do cool party tricks like little Carl did in class.
I don't know if that's necessarily
cross those out?
constituted as
Who's
cool.
little
No, we
Carl?
can't cross anything out.
Oh,
You missed the story
missed
yesterday.
it. He's a stupid little overachiever.
I'll tell it again at the end if I have time.
Is it
Stephen, can you
similar
follow
to
me over here?
Little Bill?
No. Okay.
Go.
Now. So for example, if I say that a sub n equals, it's a really simple example of it.
This is an example.
Yeah.
Hold on, so the a sub n equals the last thing on the bottom. Sounds like
Well, no, this is the sum of n terms. So like if I say a sub n equals, I could make one up.
Hold on, so are you continuing on this chart, this thing? Or is this a whole nother problem?
Whole new example. Whole new example. If I say a sub n equals 5 times 3 to the n.
Yes.
Okay? This is a fairly simple geometric series. The first few terms are going to be 15, and then 45, and then, let's see, 3 cubed is 27, 5 times that is 135, etc. But these things go up pretty quickly, right?
Yeah.
So you wouldn't really want to add the first, 10 terms of this. That'd be kind of tedious.
Yeah.
Okay? But here's what I know. I know that a sub 1 is 15. Okay? I know that r is 3. That's what's being multiplied over and over and over again, right?
Yeah.
Yep.
So if I wanted the sum of first 10 terms, if I wanted to add all this up, I would say the sum of the first 10 terms is the first term, which is 15. Okay? 1 minus, this is the annoying part, 1 minus 3 to the 10th. Is that right?
No.
Over 1 minus 3.
Yes.
Well, 15.
It's still going to be a huge number. It's going to be 15 times, I'm going to rewrite this a little bit, 3 to the 10th minus 1 over
Wrong,
positive
you
2.
can't do that.
I can, because I was going to get negative 2 on the bottom, so I switched the signs top and bottom. Isn't that tricky of me?
Oh, I see what you did.
That's obnoxious.
Basically, you just took out negative 1.
Yeah.
Or
Negative 1 out of top and bottom. 3 to the 10th is going to be a really big number. So this is going to be an obnoxious example.
Calculator.
Yeah, this is where you pull out your calculator, but still this goes faster with the formula.
3. Can you not?
wouldn't it just be like 2 and then 9?
59,049.
Pardon?
59,049.
59,049.
Divide
Okay,
by
so this is 15 times 59,049 minus 1 over 2. So that's 15 times 59,048 over 2. Incidentally, if you don't get a whole number, at the end of this you have done something wrong, because really all we're doing is adding whole numbers.